Hi YouTube, my name's Jeff and I'm the vegoilguy. A few weeks ago now I built these caterpillar tracks and I wanted to convert them to radio control but knew nothing at all about it. If you're like me, a real newbie to radio control, then stick with me as I try to explain a few things and show how I added RC to this model. If this is all old hat to you, then perhaps you can point out any glaring mistakes I've made. I'm always eager to learn. Now this is what I had. 2 motors driving 2 tracks. So how did I go about it? What's the equipment needed for basic control? How does everything fit together and work? Perhaps the obvious starting point is the transmitter. These are the control boxes. It's the boss of the system that tells everything else what to do. The user inputs instructions via control sticks or switches, and the transmitter encodes this information into radio frequency and sends it several thousand times a second. Transmitters have channels, and each channel can be thought of as an ability to do something, so the more channels a transmitter has, the more things it can do. Next in the setup comes the receiver. The transmitter and the receiver are bound to each other. Theoretically, this stops them from accidentally influencing other radio control devices that might be in the same area. The receiver usually sits inside the device that's being controlled and, as its name suggests, listens out for instructions which it then passes on to the actual doing components like servos and motors, which we'll come to in a moment. The receiver has a series of pins and these are connected to other items using servo cables. It's important to take note of the polarity of these pins. Get these the wrong way round and you could damage your equipment. Now I've just mentioned servo cables, but I'm not actually going to be using them here. Servos take the electronic signal and translate this into mechanical movement, usually in the form of a rotating arm. And there's a massive variety of these available to perform all manner of functions, like pushing, pulling, turning, etc. A speed controller safely varies the speed of your motors in accordance with your instructions. This is much more involved than you may have realised. Large, heavy-duty motors in particular draw a lot of electrical power, more than enough to fry the average human. Starting from a standstill, there's often a surge of power that can be 10 or 20 times that of the usual drain. Then there's rapid speed changes and course directions and what have you, and this can literally send your motors spinning. All of this invariably draws massive amounts of power that could potentially damage your motors. So the speed controller handles this safely, typically turning the motors on and off thousands of times each second, which maintains momentum but reduces power usage and safely converts this excess power into heat. And believe it or not, that's all that's involved. So let's have a quick recap. You tell the transmitter what you want to do via its controls. The transmitter sends this information to the receiver. The receiver then instructs devices like servos and motor controls which perform the tasks that you've requested. That's it. There's doubtless lots of information that I've not covered in this vast topic, but for me this is more than enough to get me started. So, working quite blindly, I turned to Amazon to buy my transmitter and I was shocked by the prices and the varieties that were available. In my admitted ignorance, I spotted a nicely affordable 6-channel transmitter with fantastic reviews. It was the FlySky FS IA6 and it came with a bound receiver. When it arrived I was disappointed by the fact that both the control sticks were not centre sprung. I now understand that this is because it's a popular transmitter with RC flyers, as the name suggests, and this static stick is useful to them. But for me it wasn't the intuitive sprung stick back and forth motion that I wanted. But this was easy enough to get round. I just took the transmitter apart, which isn't as terrifying an idea as it sounds. It doesn't even invalidate the warranty, as the instructions tell you this is possible. I simply rotated the stick 90 degrees and put it all back together, and now I have the intuitive spring action that I wanted. Next came the motor controller. These are expensive, but they're essential. For me, the Sabertooth 2X60 dual speed controller ticked all the boxes. It handles battle bots up to 250 pounds in weight and regular bots up to 1,000 pounds in weight. Aware that my bot was already becoming a 2-man lift, I realised it was pointless skimping, so that was the one for me. Annoyingly, no cables came with any of the stuff that I bought, and these are what you're looking for, servo cables. I found them nice and cheaply on Amazon. They've got a connector at each end, but I only needed one end, so I cut the other off. The transmitter has batteries, but the receiver needs power too, and these are often powered by separate battery packs. Fortunately for me, the Sabertooth has a battery eliminator circuit, or a BEC, so batteries aren't necessary here. And that's where I began wiring at the motor controller. We only need 2 wires to power the receiver, a positive and a negative, so I cut away a small section of the third white wire, which is the signal lead. I then marked this with a little bit of tape to make identification easier. Then I simply took all the red wires, bared a little bit of the end, and inserted them into the 5V terminal, which is the positive connection. Then I did the same with all the black leads, inserting these into the 0V terminal, which is the negative connection. This left only 2 white leads, and these are the channel signals. As this is a dual motor controller, it's expecting 2 signals, one for each motor, so 1 white went into S1 and 1 into S2. An important thing to note at this point is the dip switch on the controller. A dip switch is just a series of switches connected together, but these must be set correctly according to how you're going to use your controller. The documentation was a little confusing, to be honest, but thankfully Dimension Engineering have a really helpful wizard on their website. Simply select the motor controller you have and answer a few easy questions. For me, it gave me this setup, which has individual track control. The motor controller gets its power from the batteries that power the motors, and in my case this is 2 car batteries. Now that's a lot of juice, so I decided to isolate the batteries from the controller via a switch. As these are car batteries, I went with an auto battery cutoff switch. My batteries are connected in series to give me 24 volts, as that's what the motors require, and the switch simply sits between the batteries and the controller. The positive comes from the switch and goes to the B+ terminal, which stands for battery positive. The battery's negative lead simply goes to the B- terminal. Now these are large terminals because they're expecting thick wire to handle all that power. Either side of these are the motor terminals, M1 for motor 1 and M2 for the other one. There's no positive or negative, just an A or B, as it's largely irrelevant. The controller reverses the polarity as necessary. Now we come to, for me, what was the only tricky bit, the channels. As I said earlier, a channel can be thought of as a function, and in this initial setup I only needed 2 channels, one for the left motor and one for the right motor. So the transmitter needs to send appropriate channel information to the receiver. But when you look at the transmitter, this is a channel, this is a channel, this is and this is. Get the idea? The instructions I'm putting into the transmitter are channels, and I know this transmitter has 6 channels. The instructions don't tell you what everything is, but do read your instructions anyway. The reason for this is the manufacturers are allowing you to decide which channel is which, and that's to match your personal preferences. Now, if you've got exactly the same transmitter as me, and you want to steer 2 motors, and if you've turned your left stick 90 degrees clockwise as you look at the face, then plug the left motor servo cable into channel 1 and the right into channel 3. Then using your transmitter setup menu, select stick mode number 3, and that should get you rolling. If you've got something different, and you probably will have, then you'll have to figure this bit out yourself. Hopefully your instruction manual should get you through this, but if it lets you down, don't worry, there's nothing to be afraid of. Here's a quick walkthrough of how to get around this. Firstly, make sure all of the power is off and no batteries are connected. Take one of the channel servo cables and plug it into channel 1 on the receiver. And make sure you get that polarity right. Do it wrong and you could ruin your equipment. Turn on the transmitter. Then take the servo cable that's marked as the power supply and plug this into the receiver. Make sure the transmitter and receiver are happily talking to each other. Now, I have to say here, despite the manufacturer claiming that my transmitter and receiver were bound together, they weren't. Luckily, this is simple enough to do and will be covered in your instructions if you have the same problem. So, with everything on, experiment with the controls on your transmitter. Does anything work on your model? If it does, is this the correct function for the appropriate control? If not, you'll need to unplug it and try again. So, turn off the receiver, but you can leave the transmitter on in this instance. Unplug the servo cable and plug it into channel 2. Then turn on the receiver and try again. Now you're probably going to need to repeat this across all 6 channels on a trial and error basis until your transmitter and your model are working together just how you want. If your transmitter's like mine and allows you to swap around the controls on your transmitter, then obviously you're going to have to look at those as well. This could mean a little more trial and error, I'm afraid, but as I say, don't be afraid to swap and change these cables. As long as you turn everything off and make sure the polarity is correct, you're not going to do any harm. At some point you'll get there and everything will be talking to each other perfectly. When this is done, make sure everything is nice and secure. You don't want it falling out. Now, on mine here, everything is on a temporary basis, so it looks a bit rough and ready. So with everything latched down in its temporary testing position, I set out to see if it works, and it worked a treat. Now I liked these Caterpillar tracks when I built them, but they were tethered to me at the time by long cables. Now that it's working on radio control, I absolutely love it, and I was pleasantly surprised how easy it was to do. So that's it guys. I hope this very basic introduction to radio control was useful to you. Please remember this is the first time I've ever done anything like this, and if you're in a similar position, I hope I've given you enough information here to get you started. If you've got any questions or need any help, do feel free to drop me a line. I'll certainly do everything I can to help. If you enjoyed this video, then please like it. If you didn't, why not let me know why so I can improve my future videos. Please subscribe to my channel and look out for my other videos. And that's it for now guys, thanks for watching.